So students, let us understand next magnetic field for a circular coil. For this, what I do is take a long conducting wire. This long conducting wire, give it a circular shape like a loop, as you can see in this particular diagram. After this, take a cardboard and make 2 holes on the cardboard. After making the 2 holes on the cardboard, what you do is pass the wire through the 2 holes in the cardboard. After passing the wire through the 2 holes in the cardboard, join this to a battery and plug key in series. Now after connecting a battery and plug key in series, take some iron filings and sprinkle this iron filings on the cardboard. Now when you sprinkle the iron filings on the cardboard, after this tap the cardboard gently. When you tap the cardboard gently, it is observed that at the point P and the point Q, all the iron filings arrange themselves in the form of concentric circles. Now why has the iron filings arranged in the form of concentric circles? Obviously because magnetic field is in the form of concentric circles. So we can say here for a circular loop, each and every point behaves like a concentric circle. Now at point P and Q, you will see that all iron filings have collected in the form of concentric circles. So here I will apply the right hand thumb rule. Now using right hand rule for point P, it is noticed the thumb shows the direction of current, and as the thumb is showing the direction of current, the curled fingers show that the direction of the field is anti-clockwise. So we have understood the direction at point P. Now let us go to point Q. When I use the right hand thumb rule at point Q, now once again the thumb shows the direction of current. And when the thumb is showing the direction of current, in this case curled fingers show that direction of field is clockwise. So we have understood the direction at point P and Q using right hand thumb rule. Now let us come to the center. Always remember student, in center lines of force are infinitely big. Now a small part of a big circle looks like a straight line. That means if you have your infinitely big circle, in that infinitely big circle a small part looks like a straight line. Let's understand this. I have a very small part of an infinitely big circle, that is a small arc. In that small arc, if I consider a small part of a huge arc, it looks like a straight line. And that is why we say in the center magnetic field is in the form of straight line. Going further, what I do is I take another loop of smaller radius. When I take another loop of smaller radius and perform the same experiment and sprinkle iron filings and pass current, then it is observed that magnetic lines of force are closer to each other. Now students, we know when lines of force are closer, the field is stronger. So we can say if radius is smaller, the field is stronger. From this we come to 2 basic conclusions. The first conclusion is magnetic field is directly proportional to current. And the second important conclusion is magnetic field is inversely proportional to the radius. This means if radius increases, magnetic field becomes weaker. Also students, looking at the magnetic field on the cardboard, close to wire the magnetic field is stronger because the lines are more concentrated to each other. But away from the wire, the magnetic field becomes weaker, and you can see the lines of force are away from each other. So students, this was the magnetic field for a circular coil. Thank you.